Okay, so first the bad news. I heard from a lot of people that they're pretty swamped right now, so I'm going to have to cancel class Wednesday. But actually, I'll be here. I'll be here Wednesday helping everybody finish all their labs. But no new content on Wednesday. I'm just going to treat it as a lab period. It's optional. It's meant for me to get you through the labs as much as I can, because I think the section 3 labs are really important for you to do. So I want to make sure everyone gets through them. Yeah, do you have a question? I'm going to make the blockchain class go to class because there's less work in that class. So I didn't get, yeah, so if you're, you're not, y'all aren't working as hard as you are in here. So I'm gonna give all of you a break. But I actually do, I think it's really important because I know some of you are stuck for hours on some of these things. So the best way not to get stuck is to do it here with immediate help. Because if I am sporadically accessible on Slack, you're gonna get stuck for a long time. That's not the intent of the labs. The labs are actually meant to be pretty turnkey. So if you're actually spending hours on one lab, that's a red flag. That's not what I want you to do. Yeah, the labs, the section 3 labs.
The 4 ones are more for like the project, right? Because I was kind of thinking like, I need to get
for
those this week.
the ML API one is the one that you should do for the project. So so after you get through lab 3. So those are due this weekend. I would do that one ML API one where it leverages the vision, because that's one integration that is through a Python. I think it's a Python Flask app. That's what you're going to need to do for your project. So yeah.
So our project doesn't necessarily have to include the ML API. This is just you're saying like the act of using one API.
Yes. Yeah, and especially if it's an API that's on the Google Cloud platform, because all of those packages, including the Google Cloud packages, and then getting it to integrate into your web app, that should all be done. At least the outline for how to do that is done in that one lab, like setting up the credentials and making sure it's all integrated together. So yeah, so Wednesday class here is optional, but I'm going to be here helping people do labs. So I think it's a good opportunity for you to get through any of the labs that you're stuck on. Any questions?
That sounds like good news.
Yes, it's bad news for me because I don't get to give you it now. I was just messing with you. So today, and today is going to be quite short as well, but the lab is quite long. The lab associated with this particular thing is very fidgety, and I've been fidgeting with it for the last couple of hours. And it's almost ready, but yeah, the Firebase lab is going to take at least an hour for folks to get through. So I want to give you some time in class to actually start it if you'd like. So we're going to talk about Backend as a service. We talked in general about software abstractions, and one of the things we talked about was the API ecosystem. Another thing that people are moving towards is something that's known as Backend as a service. And these are the packages the services available. There's a myriad of services for building apps. And the idea is that you want to reuse as much code as possible that someone else has written. You don't want to write all of the code associated with your app, if at all possible. So the motivation is, suppose you're a web application backend developer, what kinds of code would you typically write? So if you're building the next social media site or the next game site, what kinds of functions would you implement as a programmer that you can think of? Credentials, authentication, yep. Routing, what kind? Oh, you mean the website routing, that kind? Okay, yeah. What other things? Is that all your app does? Authentication and some routes. A database, yep. Connecting users, maybe a chat application like Slack. Yeah, so say if you were developing Slack. Anything else? What else would you think of? Was it? Media sharing, file sharing. Yep. Emojis. Yeah, emojis. So all of these things that you need in your app for your users that you don't want to write for yourself. That's the idea of backend as a service. Turnkey backend infrastructure that attempts to provide all of these functions that you'll find in every single application. So all the stuff you need in your app, but you don't want to code yourself. So if you're good at video game programming and sort of the mechanics of game programming, the last thing you want to do is spend like months figuring out how to get communication between your players, right? That's a piece that's not your expertise. You need it. The players need it, but you don't want to have to write it because that's not what you do. Okay. So this backend as a service was initially targeting mobile apps. As soon as mobile took off, then treating the backend as a sort of a black box that you just use rather than implement yourself became vogue. Okay, so one of the things that was mentioned was authentication. So you'll see social sign-on, single sign-on. This is done with something called OAuth. And so you would like that to be programmed by somebody else. You just want to leverage account identification out of the box. Another thing is real-time database updates. So you're basically sharing a real-time backend, and as people are updating that data, everybody's UI changes. So you can think of a shared Google Doc, or in this case, Slack. So everyone in our Slack channel is probably sharing the same PDXCS backend database, and stuff is updating in our UI based on that shared view of a real-time database. So that's what this is. And so if you've been on a channel where a bunch of people are sending messages at the same time, you'll get this because everybody is seeing everybody else typing into that app. And that's done with a real-time database that you wouldn't want to actually program yourself as an author of Slack. Okay. Push notifications. So whenever a new message comes in on Slack in particular, something like this. A notification will show up on the browser. A notification will show up on your phone. So these are things that you don't want to have to program as well. You just want to implement those things in your app. So those are in the browser, and then this is something on a mobile app that if you can leverage the software for, you would like that to be done for you. Messaging and chat. So if you have to implement a chat room, you would like this to be turnkey, to just get the chat application in your app straight out of the box. In-app ad integration. So if your app needs to make money, like it's a game app on Android, you want to be able to quickly include ads and subscribe to an ad network. All you want to do is like give it your AdSense account and then just rake in money immediately from your app. You don't have to actually go in and program the interaction with the ad network. Another one that we did this manually, the automating the certificate management for the TLS certificate. So in your case, you had a web server set up, you did certbot, you issued yourself a certificate, and guess what? In 90 days, you'll have to reissue that, otherwise it'll expire. You don't want to have to deal with that infrastructure management if you're an app developer, so this is what a backend would do for you. It would automate the renewal of your certificates. And much like in your previous labs, you manually did the CDN deployment. You designed it and you deployed it. You would like that piece to be done automatically for you. You're just like, here's my site, here are the assets. You figure out how to distribute this globally in a way that makes it so that my users get this content really quickly. So that's another function. Application analytics. You want to be able to analyze low-level usage of your service by your users. For example, I want to say, what is the average amount of time that a user spends in my app every day? And how does that change over time? So you would like this backend to be collecting all of these statistics, and then for you to be able to say these questions, you ask these questions, and then it'll produce the results on your users. something you would like to do. Another one is support for A/B testing and canary deployments. So you have a new version of an app, you're not sure if it actually works, and so you would like to just deploy this to 1% of the clients, maybe 1% that you don't really care about, and then test it on them. Like, you wouldn't want to, like, all your cash cows will get the old stuff that definitely works, and then maybe the 1% of the users that you don't really care about would test out the new one. And then you want to get statistics across both of these things, and then make sure that the new version is actually stable, and then switch everybody over. So that kind of management you would like done for you, rather than you doing it manually. And these are all screenshots of this one's Firebase. Yeah, so most of these are derived from what we'll be working on with this lab. Another one that you would like to have is an automatic REST API endpoint for a lot of your functions. You would like these things to be created for you automatically rather than in your API lab. We did that manually. And that code isn't that hard. So it makes sense that you'd be able to generate your own API, your REST API endpoints on a project. Okay, so initially this came about in about 2011. There was a huge push from 3 startup companies that were all part of this Y Combinator startup incubator. So Parse, Meteor, and Firebase were the 3 companies. And it started out as a real-time database. So they recognized that game companies in particular, they didn't want to run a back-end database. So this is the initial database as a service idea. But the thing with game companies is that they needed real-time updates. They needed to be able to push state to and from the clients and have it automatically update. That isn't very natural in something like Cloud Data Store, where you have explicit puts and explicit queries and fetches. A real-time database allows you to have, so the model is that every client has a persistent connection to the backend database, and that thing is just updating those entries in the sort of the client DOM, for example, in real time. Because there's a bidirectional real-time communication between the client and the backend database. And that was the innovation of these companies. So the front-end app, either on the mobile device or on the browser even, was all doing this asynchronous JavaScript over REST and JSON. Okay. So the innovation of Parse was that it allowed those without a CS degree to create a full-featured application in a short amount of time. So I came across this because it was being used there's this college in the Bay Area, it's the Academy of Art University now, and they were just having their art students develop just cool mobile apps using stuff like Parse. And so this is cool because then you don't have to go through a four-year CS degree potentially to build something. But this allowed people just doing UI UX to actually implement the entire app. So if you just know front end, you just need a very tiny amount of code to speak to a back end, and then all the back end features are implemented for you as a service. And Parse was given it away for free because this is what they do in .com. They'll like give it away for free, hoping to get users, and then eventually try and figure out a way to monetize it. So you just have this interface to this Parse API backend, and then you just treat it as hosted infrastructure, as we've treated all of the serverless stuff in this class. It was what Parse was doing. And then Parse automatically maintains the backend. Okay, so there are some issues with this approach. The first one is vendor lock-in. It's very similar to the APIs, right? And this is similar to what happened with the Windows SDK. You build an app to one of these proprietary backend things, and your app is stuck. Like, you have to use that stuff. Otherwise, you're going to have to rewrite your app. So that's an issue. And if you want to migrate, you have to migrate both your app, you have to change all your source code, and you have to convert all your data. You have to pull all your data out of the other database and into another one. Okay, so this is not necessarily, this might be something that you want to do as a rapid prototype, but as a long-term investment, you have to make sure that this is what you want. The lock-in is what you want. And so there is also an issue of supply chain stability. So if you're in business, you want to make sure that your supply chain is stable, because if your business relies on components in that supply chain that go away, then all of a sudden you've lost your own business. And so in business, you're trying to make sure that it's predictable, right? And that you're only investing in companies like, there was an old saying in the 70s and the 80s, is that nobody ever got fired for choosing IBM. Because if you choose IBM, the chances of IBM going away is basically zero. But if you choose an aggressive startup company, like I was in a startup company, and we went under, well then anybody who depended on us, just, it's gone. Your business model is gone along with ours. So that's an issue. So this is why businesses they don't really want to rely on a startup for a core function. And these were all startup companies at the time. So Facebook acquired Parse in 2013. And everyone was like, wow, this is great. This means that this thing is going to be reliable. It's going to be supported because Facebook is not going to go under. So everyone felt like, yes, that's a good thing. Parse with Facebook. But this happened not long after, like 3 years after, Facebook decided to shut the platform down. Okay, so those relying on Parse were forced to migrate or learn how to operate the Parse backend. So one of the things that Facebook did is they open sourced the backend. But the whole point was to not have to run the backend. And so a lot of developers just had to find something else to do, basically, or host it themselves. And so Facebook got a lot of flack for this. So yeah, this is the danger of relying on technology that eventually goes away. Yes?
Why did Facebook shut it down? Did they just figure, nothing for us?
Yeah, can't monetize it, or maybe it's they wanted people to build natively in their own ecosystem. They wanted them to build Facebook apps. Any number of reasons. And actually, I have a friend who basically built her entire app on Parse, like 6 or 7 months of engineering on this like used item trading site. And as soon as this happened, was like, uh-oh, and basically had to re-engineer all of the entire site over to something else. And she ended up going to Firebase, which is what Google eventually acquired. And so, yeah, so Google acquired Firebase in 2014. And so I like this headline, trying to clean up the mess that Facebook left by killing Parse. But really, you have to think about what Google is going to do with this too, right? So will Google keep it cheap? That's one question, because they can easily raise the prices on this thing. And if your app is locked in, you're paying a big bill. Like Snapchat is paying $2 billion for App Engine. It's like, is that what you want in your business? A $2 billion charge that you're paying to Google? Maybe. Maybe if the alternative is to not have a business at all, maybe you would pay that. And so the other question at the time, because they had just shut down Parse, was, is Google actually going to eventually shut this thing down? It's not shut down yet. We're still doing the lab. Yes.
For us, it's kind of like, we just kind of set up something app and take it down, set up somewhere else. But for something like as big as Snapchat, is that a huge thing to move from App Engine to something different?
It is a huge thing, yeah. But you have to. Obviously, you can automate some of the conversion if you know the schema really well. And I think Snapchat, if they're smart, is converting away from App Engine to something. Most companies will do something like this to rapidly prototype to get VC funding. And then if they're going to make a legit business out of this, they would do something that would be more like Kubernetes and custom kinds of things where they can optimize the cost a little bit better. But it's really time to market in the startup world to get a prototype that can actually get investor funding. And I think that's why a lot of folks find these platforms attractive, because I don't want to spend 6 months on authentication. You could spend 6 months figuring out OAuth. That's how complicated that stuff is. And you don't want to be building all of these pieces. Eventually you might. If the surcharge on using this stuff is too high, then you might, implement something custom. Okay, so we're going to use Google Firebase, and this allows you to rapidly develop mobile and web applications. They have libraries for just about every single programming language you would write your app in. So Node, Python, Go, Java, and both front-end and back-end libraries. Again, iOS and Android support as well for client side. And then it's similar to the API stuff where you write code to this backend as a service API, and then you forget about the maintenance of all of that stuff. It's all abstracted away. Okay, so Firebase initially just had this real-time NoSQL JSON database via a REST API. Every data in your backend has a URL associated with it. And then that's the URL you publish and subscribe on. And then if you can think about Slack, every single message in Slack has a unique identifier. And then every channel has a unique identifier. And then changes to that identifier are updated in real time as sort of push notifications. So if you submit a change, it will get pushed out to everybody who has subscribed to that change in real time. This is how, if multiple people are on the same channel, you subscribe to notifications for that channel so that if someone posts onto that channel, it immediately notifies all the clients that are watching that channel. And that's how that particular piece of Slack works. Okay. Authentication out of the box. So authenticating with email addresses, Facebook, Twitter, GitHub, and Google credentials would be supported, are supported from Firebase. And this obviates the need to actually figure out how to get OAuth 2 to work, this is not trivial, unfortunately. Something as complicated as OAuth 2, though, in Firebase is 2 steps. Finding and adding your developer API key, and then adding 1 line of code, which is that's what you'll be doing in your lab, adding the 1 line of code to add authentication for Google, and that's it. That's how simple it is. And then automated hosting infrastructure. So automatically deploying the content in a CDN was what they were doing. Okay, so that was their initial features, and then they added all the other things that we talked about in the other slide: the notifications, the analytics, the messaging, the remote configuration, the ad network integration, the A/B testing stuff. That all got added after the fact. So now it's really full-featured. Anything you can think of that your app might need, Firebase is going to support on the back end. And this is why, like for that Super Mario run, they actually had a little bit of a Firebase icon there, because that's what they're using for the authentication, right? Like, I don't want to program OAuth 2, so I'll just use what the Firebase library gives me. Okay, so this last one is likely why Google isn't going to shut this thing down, right? This is funneling people, because obviously the ad network that they integrate well into is Google's ad network. And that's where Google's making all of their money. And so this is where you're like, okay, this supply chain is stable because it's making money. It's driving traffic to Google's cash cow, is the idea. Okay, so here's an example of how easy it makes things. So there's API access for doing the authentication in a single line of JavaScript code. So this is an example of a function that you would call to create a user with an email and a password. And if you just want that thing implemented in your app, you would just call the Firebase library thusly. Or if you want to allow a sign-in, so after you've done the creation, if you just want to be able to sign in a user and have this thing automatically check the credentials, that's all you would have to do. So you notice I'm not actually saying this is my database file. I'm going to do a bcrypt hash of the password and store that. I don't have to code up a password reset function. I don't have to do any of that stuff. I just call this thing, and then it does that. Okay, so pricing, free tier up to 100 concurrent users. So you would have to actually get a reasonable amount of users to go outside of this free tier. 50 gigs on BigQuery, 1 terabyte of querying if you want to do the analytics. I forget the other parts of the free tier for Firebase, but these are quick starts if you want to build an app using Firebase, a Python one for the back end, and a JavaScript one for a Node.js and a front-end implementation. Okay, so we're going to do the quick start. We're going to do Actually, no, we're not doing a quick start. We're doing something else for the Firebase Labs. So I'm going to go through the Firebase Labs as they are intended. So again, I just updated the slides to a version that will most likely work. I have managed to get through 90% of what's there, and if anything changes, I will quickly update and post on the channel. I couldn't get it quite to fit to the end before I had to come to class. Okay, so you're going to do one lab, and the lab that you're going to do for Firebase, the first thing you're going to do is there's a separate console for the Firebase project. So you're going to go to the console, create the Firebase project from the Firebase console. There's a picture of it to add yourself. And then you're going to click to register a web app. We're going to do a web integration into Firebase. So you click the that part of the icon to register your project as a web application. And then you're going to register this app. It's called Friendly Chat. This is a real-time Slack sort of knockoff is what you're going to implement. And then you're going to set up Firebase hosting, register this app. And then you're going to configure the project. The first thing you're going to do is add an authentication provider. And if you click on authentication, you click on sign-in method, looks slightly different than this, but you'll be able to navigate it. You can see that there's all sorts of sign-in providers that are supported. Like there's Facebook, there's Twitter. What I want you to do is click on Google, and then enable the Google sign-in, the sign-in method. And then it'll ask you to name your project, so you name it and then you save. And then the other part is to configure the backend real-time database. What's going to happen is that we're going to deploy a chat application that allows multiple clients sharing this page to automatically update their UIs in real time. And the way this is done is through the real-time database that Firebase initially started. So there's two databases, just like in Cloud Data Store. There was Cloud Data Store, and then there was a Firestore mode. We're going to use the other one. We're going to use the Firestore mode, but it's pretty much equivalent. It's just a real-time database, both of those things. So you're going to create the database and then start this in test mode. You're going to set up cloud storage. So one of the things that we're going to do with this is you're going to be able to send images into this chat app that other people are going to be able to access. In order to store those images, we're going to need a storage bucket, and that's what this configuration is going to do. And then you're going to go back into your Google Cloud Console. And the reason why we're going to go back here is because we have to associate the project that we just created with a billing account. And I don't know why you can't do that in the Firebase UI, but basically the Firebase project that you just created will show up in your Cloud Console on Google. And then you just enable billing on it. And the way you enable billing on it is you go into Compute Engine, and as soon as you click on Compute Engine in that project, it'll say, hey, you have to enable billing in order for you to pop up a resource. You're not actually going to create a VM, but this is the easiest way to actually enable billing on your Firebase project, the most straightforward. Okay, and then what you're going to do is you're going to launch Cloud Shell, and you're going to clone this repository, Friendly Chat Web. And then you're going to go into webstart/public, and you're going to install the Firebase tools in the console, because these Firebase tools will give you the command line for deploying the Firebase app, is what this thing does. And then you can test that it successfully created itself when you do a Firebase version. And then what you're going to do is you're going to authenticate your session, your Cloud Shell session, with the Firebase app. So you're going to do Firebase login, and it's really important. So if you actually do the code lab, if you click on the code lab link, they don't have this in there. You need this in order for it to work. The --no localhost. You click on that, and then you authenticate your CLI with the backend Firebase, and then you'll have to allow Firebase access to your account to do this. And then as part of this, you're going to copy the code. After you do the login and after you do this allow, you'll get this UI that says copy and paste this code into the command line. And when you paste it, you'll be logged in. And this will allow you administrator access into your Firebase project. So that's all you're doing in this step, authenticating your Cloud Shell to the backend Firebase project so you can do all the deployment that you need. Okay, and then you're going to say, I want to use a particular project. So you're going to say for your command line session, I want to use the project that you just created. You should only have one. So this will be an easy thing to select, the one that you just created. And then you can create the alias if you'd like, but then you have your Firebase project all set up, starting in this web start directory. Okay, the next thing is to edit the homepage of this Friendly Chat app. And if you look at this, this is the way you include the functionality for Firebase. At the very end of the HTML, it's all JavaScript libraries that you're going to call into the backend with. You can see all of the parts of Firebase that you're going to use are included as scripts, followed by this init file. And this init file is going to have your project sort of parameters automatically included. And then your main Firebase script that implements all your functionality for your app is in main.js. Now initially, main.js has a bunch of functions that are just stubbed out. And what the lab is going to have you do is just incrementally copy and paste the functionality into these stubs. And you can see how easy it is to augment this particular app with Firebase features. And it's like you're basically copying and pasting like maybe 5 or 6 lines at a time, and then getting functionality added to your app. So that's it. And so once you have done this, you can say Firebase serve and then -- only hosting, and it'll give you a URL. It'll bring up a local version of this thing. It's very similar to the DevApp server. It's going to bring up a local version and then serve it from port 5000. You can click on this, and then what you should get is something that looks like this, Friendly Chat. You don't actually have to do this if you just click on this link. It'll automatically bring you to this thing here. But the app isn't fully functional yet, so that's just the shell. And so now what we're going to do is we're going to go back into the code and start adding functions to this app. One of the things that I want you to do after you have launched this thing is when you're at this app, you right-click and do a view source. And when you do a view source, you'll see at the bottom of the HTML, you'll see all of the JavaScript that got included. If you click on init.js, you can see that this particular thing is associated with your project. So you can see where the backend is hosted. Okay. You can also see the project credentials. This is in test mode, so that's why. But that's basically like this is for you to know that it's there. Yeah, that's usually a red flag, but this is why we're in test mode, so that you know that your thing got configured and it's using the right thing, the right backend. Okay, so the first thing we're going to do, the Code Lab has you do, is add Google authentication to your app. And so this is what you do. You say, hey, I'm going to set my provider to Google Auth. So 1 line of code or 2 lines of code, you instantiate the provider, and then you say sign in with that provider. So it just gives you the one option, and that adds Google authentication to your app. And then, of course, you want the sign out as well. So those 2 functions are there. If you want to be really fancy, let me see here. Okay, the other thing is whenever when the authentication status of a user changes, then basically this function gets called. And one of the things that this thing calls is that if you log in with your Google account, then what happens is you have this profile image that's associated with your Google account, and the Friendly Chat app wants to actually show that. And so that the little thing in the picture in the circle that you would see, like Slack has it as well, that's what this thing is doing. It checks for when users have logged in, and then it will automatically, when they've changed their auth status, and it'll automatically try and grab their profile picture, is what this piece of code does. And it also gets their username. So in the upper right, when it says sign in with Google, when you click on that and sign in, it's going to show your profile picture and your name after you've logged in. That's done with these lines of code to change the UI. So that's pretty simple as well. Okay, and then this is the underlying code for doing that. So it's very simple. It's like, if I'm not logged in, just use this placeholder image. And then if I am logged in, I just use whatever this photo URL is in the schema that Firebase implements. So it's really simple. Same with the username. The display name is the schema that actually updates the name of the account once I logged in. And then finally, there's a predicate that makes sure that you're logged in for some of the features. So that's it. Those are the only things that you copy and paste into this app, and then you end up, you do another Firebase serve. One of the things that you have to do when you do this Firebase serve is that you have to enable authentication, basically the Google authentication from authorized domains. And so this prevents other people from using your project. So one of the things is the authorized domains for allowing this sign-in method is done with, this is if you do a Firebase deploy. This is the default URL for your site. You can add custom URLs to it. So if you have your own DNS name that you want to associate with Firebase, you can add it here. The dev app server has its own URL. So when you do a Firebase serve, it has a URL, and if that URL isn't actually added to the authorized domains. So if you're going to test this using Firebase serve, you have to add the dev server name to this thing. And this is not something that shows up in the code lab, which is why I have to update the code lab with this. So this is something really important. Your thing won't pop up a sign in with Google unless these things are set appropriately. So when you get to that point and you click on sign in with Google and you see a window show up for maybe half a second and it disappears, this is what's going on. Okay. The other thing that can happen is that the way it does the login is through a third-party cookie, and if you have blocked third-party cookies, if this is actually turned on, then you have to go in through your browser and turn it off. And this is the way this particular thing does authentication. So that's the other thing that will prevent you from being able to authenticate with the Google credentials. So these two things are not in the code lab. I just wanted to show you this just to make sure if you get stuck, that's what's going on. If it doesn't show up, this is what you need to look at. Okay, so then update the app. So you can Control-C the previous version and then do a Firebase serve again. And then you can click on the link, and it'll give you this sign in with Google thing. When you click on that, it will ask you to sign in with one of your accounts. And then when you sign in, you'll see your name change, your icon change, and then you'll see the rest of the UI there. So that's sign in that got implemented in this app. And now, so you'll see that this app sends and receives messages. And so we're going to implement those features. So this is the save message. So when you type in a message in the UI and you click send, what this is on the back end is it's going to take that payload and save it back into the real-time database. So this save message says, I'm going to store this in Firestore in a collection called messages, and I'm going to add it, and this is very simple, similar to the put. You remember the Cloud Data Store put? I've just got key value pairs. And it's got even a timestamp. It's just like that guestbook entry, pretty much. It's got the message. Well, it doesn't have a profile picture URL, but name, text, timestamp. That's all it's doing. It's inserting into that real-time database backend. And then the other thing you're going to do is load a message. So you're going to register a handler so that when the backend messages collection changes, it's going to update your UI. Is what the load messages thing. So it's basically adding listeners, front-end listeners that will trigger when that collection changes. And then it's programmed to display the last 12 messages of the chat for fast load. Okay, so the code is in the next slide. This is a little bit more complex, if you can see this. It's going to query your collection called messages. It's going to order them, sort them by timestamp in descending order, and it's just going to take the most recent 12. And when it does that, then it basically, this registers the callback to change the UI on the front end. And since I'm not going to get into this because this is, if you are taking the full stack course, this is just basically doing the callback to update the UI without having to do a reload on the whole page. Okay. So you do that. You do a Firebase serve again, and then you can sign in with Google, click on messages in the message box. You'll see messages getting sent into and out of this friendly chat UI. The UI will automatically update, and then what I want you to do after you've sent a bunch of messages, I want you to go into the backend database. So back into the Firebase console, you'll click on database, and within database, you've decided you're using Cloud Firestore. And within Firestore, you should see a collection called messages, because that's what your app is using to store stuff. And then within messages, you can see all the different documents that got added. And for every message in that chat app, it creates a new document with a unique ID. And if you click on this, the last message that I created has my name, my profile picture, the text that I entered, and a timestamp. So I did that 45 minutes before class started. And then one of the things that is associated with this particular code lab is that you can then go and you can do the Android version of this and the iOS version of it, and it'll all interoperate with that same app. So this is where you have an app that you want web and mobile together. It does both of those. Examples for both of those are included here, but we're not going to do those. Okay, one of the things you can do is like, hey, I've got this UI to this backend database. I could just manually add a bunch of entries myself. So that's what I want you to do next. You can add a document and then create a new message. So create a new message, you specify a name as a string, specify a profile pic URL as a URL that's also a string, specify a text string as the message, and then you can configure a timestamp to set today's time and date. Set it to today's time and date. And so this is an example of just adding it directly into the back end. And then when you add this thing directly on the back end, the front end UI will automatically change. That's the real-time database aspect of this. So when you go back, you can see that that message gets entered into the UI. So that's the next step of this thing. Okay, the last part, well, the second to last part is to implement image sending. I have not tested this yet. I'm going to test this as soon as class is over. I think this used to work. I don't know if it works anymore, but I'm going to make sure it works before I have you all do it. So stop here until I tell you it's all good. And so you're going to be able to attach an image to a message and then have it show up on all the clients in real time. Okay. The code for doing it is included in Save Image Message. Initially, what it does is it creates the message in the backend database, and it creates it with a message loading icon. And then it'll actually take the file parameter and store whatever you uploaded into cloud storage. When it's finished loading this thing, it gets the URL. Once it's uploaded into storage, it gets the URL for the file in this Firebase storage, and then it will update the URL to show the image in the UI. So that's what the code is doing. This is the code for doing that. So it adds into the collection, the messages collection, it adds the username, the image URL, a profile pic, and the timestamp, as you saw before. So instead of the text, it's got the image because you sent it an image. And then when it's done, when this thing has been finished adding, then you're basically going to do the upload of the file, and then get the URL for that thing, and then update the image URL from above with the new URL that's pointing into Firestore. Okay, and then that will automatically update the UI for this thing. Okay, so that's the code. And then what you can do is when you click on this, it'll ask you to attach a file, and then the UI will update with the image that you've just uploaded. So I'm gonna test this thing and hopefully let you know that it does work. Okay, you can see the file. I want you to go back into Firebase storage and see where the file has shown up. And then this is actually old. This is an old UI. I have to update this. But then go back into the Firestore to show the message with the image URL associated with it. I need to update these two things. They're not quite. This is what they used to look like. Okay, so that more or less wraps up the lab. I want you to skip step 11, 12, 13, and 14. I put the slides. The walkthrough of those steps are after here. If you really like this stuff and you want to finish the stuff, there are some little quirks in the code lab that I've sort of included in the slides that follow. But you can skip all of this stuff and then go straight to the last step, which is to do a deployment. So what we want to do is, before we're just serving it in our DevApp server, we want to actually have a live URL, just like App Engine. We deployed this thing. So the first thing we do is specify a manifest in web-start Firebase JSON. We say that, hey, our public assets, the assets for the site are in the public directory, which is where this stuff is stored. And then you just do a Firebase deploy. You'll get a URL. And what I want you to do is share the URL with someone else in the class, or you can share it with me so I can sign your app. And then you can see multiple people sharing the chat app together, and then show a screenshot of that. Okay, so that's it. This is optimistically going to take you 40 minutes to do if you run into no bugs. So, yeah. Okay, so I'm going to stop here. Are there any questions? Just let you work on labs for the rest of the time. So, questions? Okay.